Okay, hello everybody. Yeah, I'm the last one between you and the lunch. So let's see how long I can actually interest you in anything. I would like to start the talk with a short quote. It's about 20 years ago. It's not about architecture, this is about design, and it goes into some of what Didier said. Just wanted to show that when I looked up things for the talk, that was one of the things that I found sort of in passing on very old mails. Leslie lost his argument. We are actually using the underscore these days in the LaTeX3 language. But as I said, this is design and implementation. But it was too nice. Yeah, a timeline. 1982, we had Tech2. And 4 years later, there was LaTeX 209. So actually what we were talking about here is two timelines. Another 4 years later, in the 1990s, there was Tech3. And then 4 years later, we had LaTeX 2E. And then there's a little bit bigger gap. And then we have Lua Beta. And so what is in 212? Well, if that timeline is correct, it should be this one. But I'm not going to talk about these predictions. People have seen that slide from the current project team, and they said, well, maybe not 212, maybe 213. But that's not the topic of this talk. Topic of this talk is something that goes completely in the wrong position. God knows why. It's a PowerPoint. Never mind. What I was trying to show is that actually around here we had the first try to get to new coding styles to have an underlying language, XPL3, and we actually built a kernel with it, and we had an architecture built for LaTeX3. That was 2 decades ago, and the question is, what happened with it? Yeah, what happened? First of all, this is actually a screenshot of this manual, which I still have, which is printed and processed in this kernel that we did back then. It took ages to actually compile, but that's the code we had back then. So why is it not actually there? Well, reasons for failures. Basically, I would say we had the kind of right architecture, but it was the wrong time. And why? Well, a couple of reasons. First of all, we were quite a bit too radical in what we were trying to do back then. And it was too experimental, and it was immature. Immature in the sense that we couldn't actually fully, to ourselves, explain all the ideas that we had. It makes it even more difficult to explain that to somebody else. But, there's one more thing. It was far too slow and far too huge going from that architecture to an actual implementation. The actual implementation was, at that point in time, absolutely not possible on tech, or at least not in a practical sense. So what we did instead, we actually solved the burning issues first, which was the 1994 point, where we released LaTeX 2E, which, in my opinion, did a good job on going from the situation we had with 209 to more structured, to solving additional problems, bringing LaTeX actually quite a lot forward. But as I said, that's not the architecture that we had in mind. That is, the LaTeX 2E version was really the old architecture of LaTeX and fixing individual bits and pieces like fonts, like internationalization, etc., etc. Okay, so yeah, this is another old email that I found from this time. And as it says at the bottom, it's nice but impractical. And that was true. It was too big, and the machines were too slow. I mean, they were better than the first days when I started with tech. But our attempt to build this new architecture ended up making it worse than the first days when I had tech, and that was something like half a minute per page then. So that's when we gave up on this, at least largely. Okay, so what was this kind of architecture that we were trying to do? What were the drivers? Now, one of the important driver was that there was no consistent design model. And what does this mean? You have a bunch of generic commands like star check sections and a little bit for table of contents, concepts like this, but very limited flexibility and limited scope. And as a result, you have basically this. Whenever you try to build a design that is not already given by somebody else, you have to go into programming. You're not actually designing, you're actually writing a lot of @ signs and backslashes and what have you, and debug it afterwards. And the other important part, which was also, or is also a driver, is the last one. We do not actually have proper management for logical or visual context in LaTeX. Now, what do I mean by this? We have a bit of logical or structural context in terms of lists. Yeah, you have these structures up to 4 levels of list or 6 levels of list with indentation being managed by the level of the list. You have some structure there with the different enumerations and those kind of things, but that's about it. You have a little bit on footnotes and mini pages. Again, you have the footnote behaves differently there, but it is all fairly hardwired into the kernel of LaTeX3 and LaTeX 209, and anything outside of that is actually not there. Well, I could have given 2 more or 3 more examples, like section after section has a logical context that is built in, but it's hardwired. You can't really change it. You cannot change the amount of space, but nothing else. Okay, so let me give you a typesetting example here. We have a couple of potential things that we want to typeset, like a scroll, maybe a book, maybe a newsletter, who knows. And that involves a bunch of people. And I'm going to introduce some of them to you if you don't know them. Let's start with the guy on the top right. It's Mr. Jack London. I chose him, well, because he's an author, he has written stuff, but also because he's dead and I could use the picture. These days that's not unimportant. So, if we want to typeset something of the works, ideas that this person has done, then the first thing that we have to do is we have to codify it in some way. We have to write it up and actually mark in some form or other the structure of his thoughts, of his work. Since the guy is dead, it might be me that is doing this. It could be in LaTeX, it could be in XML, it could be in some structured form. Basically, this is giving you the structural content of the work, whatever it is. Now, comes those people into play. If I introduce you, this is Herman Zapf, 2006 at Eurotech somewhere, can't remember. And this gentleman is Jan Tschichold, a fairly famous designer in his days, last century. So those guys, they actually help us or decide how something should look like. I mean, this guy, for example, were long with penguin, and a lot of the penguin style were due to the way he wrote up things and said how sections should look like for those books, how things should be indented, whatever the style should be. So those guys may tell us how this work should look like that we so far have just encoded in a structured form. So, well, this is just fonts, but it's not fonts, it's all sort of the design that those guys give us. So are we finished? Not quite, because somebody actually has to implement whatever they have as specification. I remember the first time I did a book with Addison Wesley, first companion, I got a 20-page design spec that told me in various glorious detail how this should look like. And I was the poor guy who had to make that happen in LaTeX then afterwards. So basically what we need is a couple of people who actually in some way or other do this for us. And if I may introduce, this is Will Robertson. Some of you may have met him from the LaTeX3 project. And this is 7 years ago, and I'm supposed to say that this is not beer, it's juice. And this is Joseph Wright. People may know him from his activities on CTAN and other places. And this is Bruno Lefloch, a recent member of the team somewhere in Africa last year. That's about the time when he joined the team. Cutting up a cake for some occasion, I don't know. Okay, so those people, they actually help in implementing such designs given by the other two. But are we now done? No? I have one more task. Because actually, we may want to fix the design according to the situation we have in real life. We have to go in if we want to have high quality and adjust. And we have to better have a way to do this. And this is one of the really strong points of the current LaTeX. We have separation in structure and form, but we have the possibility to actually go in and adjust to get the last 20% in quality in a certain publication if we want to. There's a way from top down, from this level up, to influence whatever has been implemented down there. If we are unlucky in a very bad way, by actually needing to code something, if we are lucky in a structured way by having additional code functions that do that for us. Okay, so looking again at the designer side. So this guy has made a lot of designs and said how things should look for us. And with those designs, what we can do is we can work on distilling the individual designs into some abstract design. Abstract in the sense that it is still flexible and gives us the essence of the individual designs. It could be more than one abstract design if we're talking about different things, obviously, but even if we're talking about the same thing, say a heading, it may not be one single abstract design, it may be a couple of abstract designs because the type of headings are so different. But the idea here is that from one real one you go, or many real ones, you go to something more abstract. And for this you can provide a generic implementation. And to do this, what you need is an underlying support language. And if you have all these down there, then essentially you also have an offer back, because this abstract design is something which you can parameterize, adjust to become one of those. And that is something you can give back to designers, say, here's the abstract design. Is it all? Again, no. Whoops. Yes, it is all. So this is the way around. Again, Will Robertson, 1 week ago, somewhere in Australia. He plays now the designer. So what he does is he selects an abstract design. That one has parameters. Then he selects values for the parameters. And depending what he selects, a certain set of value would give him design A, and another set of values would give him design B. And another set would give him even more designs. Not even those that had originally came from here. but some that are in the same kind of area of possibilities, according to what we have down here. So that's sort of a very generic approach here, but we are not quite ready. What we also need to do is to define context. Context meaning in the sense that this design up here may need to be changed depending on how it actually appears in a document. So a section may have a certain amount of space in front of it, but if it is immediately followed by something special before, you may want to have a different amount of space. So you have a context where you want to modify that design to some extent. So this is something we need to provide. And as I said, we also need to provide a way to even go in at a much later stage, because this is still structural or visual in the way it comes out, but this is sort of fixing the final product. Okay, so much about templates. So what are the functional principles that you can sort of take from these two examples? And so functional principles for the architecture is really, on one hand, a clear separation between user interface, stuff that structure is coded in, the design part, how these elements should actually appear for whatever you do, and the coding of that design. It's three different, in some sense, completely different tasks, which potentially different people doing it, not necessarily, but separating them gives you a big advantage in terms of reuse and flexibility. The second point, I already mentioned that before here several times, logical and visual context is very important. You need that if you want to have really high quality. If you don't have that kind of mechanism, you have to do it either manually everywhere, or if you can't do it manually everywhere, you just get less quality. Okay, then there's a big missing block. This time it works. Huh. Yeah, this is what I really think is the strong point about, if you look back, about tech and LaTeX in particular. We do have the best of both worlds in some sense. We can get the 80% more or less automatically, and we can get the 20% if we want to spend the time on it. And all this, I would say, also as a principle, needs a good underlying programming language. Well, why would you need this? It's all there. It's macro and add signs, isn't it? So, and coding styles. It needs coding styles. Okay, so here's the architecture. I have no clue whether you can read anything of that. I can't from here. Well, I'm going to try to explain that a little bit. At the very bottom, we have this underlying language, which is fairly complete by now. It is not just 4 modules, but it gives you all this kind of stuff like data types, I/O, graphics, color, programming logic, etc. That's called LaTeX3. The second important block cuts across 2 layers, really. There is this typesetting element layer, and there is the class design layer. And this part here is the one that actually defines something like a DTD. On one hand, we have here a repository of object types. An object type, an element object type, is basically something abstract like, say, a heading. And what kind of input would a heading want from a source document? And that's defined down here. We have a bunch of those here. And on this level, you build basically the DTD. You say, I have 3 levels of headings, an A head, and B head, a C head. They are all of type head. And they interact in a certain way with each other. So this is kind of where you get your article class or what have you, your Elsevier DTD specified. And this is one such thing for one type of document. I mean, of course, you can have several that nearly identically do that. But the important point, and this is one of the problems with current LaTeX, is that the article class, for example, is actually both the DTD as well as the implementation of it, and it is not very clearly separated, and therefore, if the AMS wants to sort of extend it, it's still called article quote, it's called AMSARC, but it is actually a different DTD because they have started to add additional commands. And the tugboat class is also more or less an article, but again, they slightly changed it. But there's no such thing that actually sort of gives you the abstract part of it. And that resulted in many of those slight variants that then bring problems if you want to change from one style to the next. Because there's only one or two classes in current LaTeX that implements article in the same structural form. Okay, the second point then is more the designer side of it. Down here we have those templates, those generic designs that have been implemented by people like Will, Joseph, other people outside later on, implementing a certain template for, say, a list or for a heading with a certain number of parameters to parameterize to get to detailed designs. And up here, somebody, a designer, could select a heading, select a template, sets the parameters for the template, and this way brings an instance of that to life, which is then linked to the abstract elements. The third component, again, cuts across two. This is the GUI interface layer. There you have however the documents should look like in the source. It could be something like LaTeX3, begin, brace, open, something, star commands, bracket commands, this kind of thing. It could be some XML-like, HTML-like interface. It is actually separated from this one, so you could have, for the same document type, different input formats that completely run through the whole cycle otherwise. Right now, what we currently have is one thing that is closely to the LaTeX3 syntax, but there could be more. And the idea is to have those kind of things properly separated, so you can have, for the same abstract class, different realization, depending on what the needs are. Okay, one other point, very important, that's the part that overrides. And you see here quite nicely that from the document level, from the real document, it goes really down into this layer, if you like, because it changes the parameterization of that template that has been used. You have a heading that says 2 centimeters above, but for some reason on this page you want half a centimeter less. If you want to go in there, you're actually changing whatever that instance is. And this is what making these kind of things unique and difficult to manage, and the extra effort from automation full to the end, but then also to better quality. And finally, we have a kind of support part in XML3 or above it, which is sort of supporting these different layers here. There's stuff like font management, language management, galley management, so paragraph building on galleys. I'm not going to talk about this. We talked about templates. I'm going to talk a little bit about LDP, whatever that is. This is the context mechanism. And I'm not going to talk about this. This is the support for this GUI layer. Yeah, I said I'm going to do a little bit more on this one, if time permits. So this is the whole thing in a little bit more detail. Very quickly, here you have the object a repository, something like a list, a heading, a float, and so on and so forth. You have templates for those, one or more than one, for example, a template for display lists, for inline lists, for, I can't read it, display heads, those kind of things. Here you have your abstract class DDD that takes those and says, I want to have certain lists, for example, an itemize and a whatever that is, enumerate and so on. And here you have the design being done for this abstract class. And then you have an actual itemize, an actual description list with certain parameters being set for you. And in addition, you manage the context text of those. In other words, you define how those definitions or how those settings modify depending on the context. And that is really what makes up the design layer then. And on top here on the outside you have the GUI interface that is completely separated from the other one. So whatever you choose, I mean, it's not separated from this one, but whatever you choose here should be independent of what you have chosen here. Okay, so last big block is this LDB. The title is very old. The name is LaTeX database. You're thinking it's a bad name. It might end up being Element Relationship Management, so ERM. But I'm so used to it. 5 minutes, that's good. Should fit. I leave it for now. So what is this? This is nesting and sequencing of structural elements in the document. That makes up the context. So, and elements in the document, they belong to one or more classes. So, for example, they belong to the class list. That's a generic thing. Or they belong to the class itemize. That's a fairly specific one. And when we encounter those elements in the document, then we internally update the context, and any rule that has been defined for the context that is applicable is being carried out. That's the idea behind how this mechanism is going to work. Now that's abstract. That's roughly the draft notation we are currently using. This is not final. Basically something like angle bracket list means start of some environmental form of class list. The next one means end of such an environment of class itemize in that case. That means a completed environment. That's sometimes interesting in sequencing, that you know that you're just there. We are currently thinking about this one as well. This is kind of open. The current syntax is different, but the point is, in LaTeX at least, we are not just begin-end structures, we also have individual commands, like a section is not actually a structure. It could be implemented as begin section, end section, and in some sense that is, for some cases, would be much better. But it could also, and currently it is not implemented this way. And we are going to think about supporting that as well. And this would then mean such an element which is sort of singular. And you can have loose nesting between those items, you can have tight nesting, and you can have sequencing. So to give a couple of examples, a head that is immediately followed by a list would be indicated like this in the structure. Two lists that are nested into each other at some level would be like this. Any kind of list which inside an itemize is being started would be indicated like this. The end of a list followed immediately by another list, namely by an itemize, would be indicated like this. And here's another example. If you have a float and a completed caption inside the float and another caption just starting, that would be a second caption inside the float. You could make it an error, you could accept that as a valid input and do something special. That's the idea, and you can make that more complex. This is just giving you roughly possibilities. So, I have a live demo, which probably takes about another 5 minutes. We can jump that, and then I have 3 or more quick slides at the end. Depends on what you want to do. Otherwise, I conclude without the live. Depends on where the...
2 minutes. You want to see the demo?
Well, yeah.
All right.
Yeah, it's a must before lunch.
Go for the demo.
Okay, let's try that. And this is really work in progress, so even through the original ideas are very old. So what you see here is not much space on this screen. Basically a test file, and first of all you see a template interface. This is in comments because I just wanted to show that here. It's defined elsewhere. It's a simple minded template for lists, which is effectively implementing the LaTeX3 version, having the same kind of parameters. You have a set of parameters which you can set. This is showing how the definition part of it. And then you see here an example instance of that could be set by a designer. 4 values have been set. More values could be set, the others are taken as defaults. And there are a couple of more of those. We can jump this one. This is absolutely currently just for testing, so I'm not going into this. This is, again, the syntax is not really the way it should be. By the end of the day, it's more the functionality that we're currently testing with it. This is an example of you have this context, a list inside a list, the left margin is increased by 20%. If the third list appears, the left margin is only increased by 10%. Sorry, by 10 points, not percent. Okay, and here's another example. The item text is being set and the size doesn't quite work. So I'm not going to go into very much detail. Here's a long thing that then sort of implements this. And just instead of looking very long into the details, just run it for a second. And hopefully that actually works. Currently a lot of debugging code coming up. Yep, something is showing up. So how do I get this bigger? On a small screen. So I'm not stating that this is looking extremely nice. It is largely to show various sort of possibilities, and that's the result coming out of it. So for example, the indentation of the itemized list, they have a star but no indentation on the top level. So if we quickly go back up here to the, where was it? Come on. To the declare instance, we changed that one here to 10 point. And run this again, hopefully a little bit faster. Chip, seen. At least on my screen it looks indented now. There as well, good. So that's not an example of context, but it's an example of how the sort of setup parameter of the templates work. Now, context, where's the next? It's too small. Screen is bad. So here's one that I commented out. This is now saying if we have 2 lists inside each other and the third one is an itemized, then let's change the left margin to 70 points indentation. Only then. Now let's make that smaller. Let's see what this does to our document. Nothing. This is because the screen is too small. It's down here. I should have shown it at a different point. Here you see suddenly the indentation going further out, but you don't see that it has changed. So I hope you believe me.
Oh, you can comment it out.
I can comment it out, but then we are getting to more than 5 minutes.
Yeah,
Where is it? Where is it? There.
yeah.
Okay, so that's just this one level of list that is now affected in this particular situation. So I had a similar test. Yeah, for example, this is is probably a strange one. If three enumerates come after each other, the third one is actually sort of not using the standard template for enumerate, is suddenly using the itemized template, and it using fbox with an X instead. And I think this is on the top here. Let's go again. And final example with the continuation. This says, if itemized is immediately followed by another itemized, then let's make a special label. And I think that's again on the bottom somewhere. Now this is not supposed to show, yeah, very much on the bottom here. Okay. Not to show actual design. It was rather to show various possibilities that are currently in this spec. And you can think of basically anything else being adjustable this way at various points in the document according to what the logical context of it is. So, that was a live demo. Conclusion. Nothing in this architecture really requires tech, so far. I mean, the implementation was being used, but, and that's the difference from 20 years ago. Nowadays we actually can, because the tech engines, not necessarily tech, but anything of the followers from tech, are powerful enough and big enough and fast enough that we can actually implement it inside tech if we wish to do so. So that's basically why we think that nowadays this kind of architecture can work, well, while it couldn't work in 1991, 1992. That's a picture I just skipped over. That's the current kind of kernel. It's actually not even the latest version. It shows the Expo language on top, and it shows in the middle. The red parts are sort of attempts that we have to redo of the designer level stuff. But all in all, we are actually fairly far in bringing all these ideas together now. So, quick summaries on the activities. What we did in 2011 was, first of all, Big Bang. As Joseph said it, that was documentation and code cleanup. So this is the 91 version, if somebody's interested to look at it. It's about, I don't know, 80 pages of manual. Now we have about 300, I think, just manual, and then more on documentation. A lot of speed stuff, interesting. We are here at GitHub now with the kernel, SVN, and a bunch more. You can read that in the slides. Outlook, since he's coming, there's not much to say about that as well. We're trying to do this integration properly. I mean, the interfaces that I showed you were not meant to be final. They were just technical. Output routines is probably the biggest one that is coming, and like to finish with this one. It's sort of the opposite of the one that I begin with, and that's about it.
Okay, thank you very much. We have time for questions? Okay.
Just very quick question. You mentioned C units, C unit text at the last slide. Do I understand you properly that this L3 kernel, you can run it 3 times faster than this 2E kernel? Is it correct?
Sorry, I'm not quite sure. Is it correct what?
Is it correct that I have a document that used C unit X in it, and I use L3 kernel, it's now much faster?
No, this was this one.
The
Yeah.
second one.
Basically, we improved the kernel code a lot. This is largely due to Bruno, who went over and basically redid a lot of this.
Yeah,
Yes,
but faster than what? The previous version or 2E?
previous version that we had. So the kernel got about 3 times faster.
Okay, thank you.
I'm not sure how much slower or faster it is compared to the 2E version.
Other questions?
No, time for lunch.
Okay, well, thank you very much, everyone.